We all build asynchronous applications using Node.js due to its built-in event loop. This built-in event loop gives rise to Node.js's asynchronous behavior and its concurrency model. Concurrency in Node.js is achieved using a single CPU thread. In other words, all applications run inside a single CPU thread. JavaScript on its own is synchronous, but Node.js allows us to utilize more than one CPU core when building our applications. Node.js comes baked in with a built-in module that allows us to write programs that utilize more than one CPU core. This module is the child process module, and today's video will focus on how we can build on this module provided to us in Node.js to build multi-threaded applications. So let's dive into what we have for today. First, you don't need to configure anything to start writing multi-threaded applications with Node.js. So let's go ahead and import the child process module in our application. For the examples in this video, I'll be using the Node version 16. So if you're running a much older version of Node.js, then I would suggest that you take your time to update your version. The child process module provides us the ability to spawn sub-processes. What the heck is a process and a sub-process anyway? When we use the node index command to execute a Node.js application, it creates a process. The word process is arbitrary and it refers to the program and its execution context. All of this is done using a single processor core on a single thread. A sub or child process is another execution context or thread that our code can utilize to execute CPU-intensive tasks without blocking the main thread. The child process module provides several ways to handle the process of creating sub-processes. The child process has the following methods defined on it that enables us to create child processes. We have the exec function, the execFile function, we have the fork function, and last but not the least, we have the spawn function. So let's start with the exec function. The exec function spawns a shell and then executes a command within that shell. We can execute any shell command we like inside the exec function, and the syntax is as follows. Where command is the command we want to execute, options is an array of arguments we want to pass to the shell with the command, and last but not the least is a callback function that will be fired when the process terminates. Let's import the child process module into our file and store it in a variable named child process. I'm also going to import the util library, which we'll use to promisify the exec method on the child process. So exec is equal to util.promisify, and we pass in the child process.exec function as an argument to the promisify method. The promisify method converts a callback function to a promise in Node.js. Let's create an asynchronous function, do something. Inside this function, we await the result of calling the exec function. The argument we pass to it is the node-v command. We destructure the error object, the std out, and the std error from the child process. If there's an error, we log out the error to the console and we return from the function. If the std error also contains any error message, we also log it out to the console and then return from the function. Otherwise, if everything is fine and there is no error, we console.log the response, and whatever we get from running that shell command is what we are going to get as our response. We call the do something function and run node app.js, and the result we get back is version 16.16.0, and this is the same result as running node-v. The execFile method, which exists on the child process, is generally considered to be safer with user input than the exec function, because the execFile function does not create a shell outrightly. We create a variable execFile which is equal to util.promisify, and we pass in child process.execFile, and this line just converts the execFile function to a promise, so it makes it easier for us to work with. Inside of do something, we change the exec function to execFile. Now we remove the -v flag from the command since it's an argument to this command. We need to put it in an array and pass it as the second argument to the execFile function. I'm going to go ahead and save this file and then run it from the terminal, and we should get back the same result again. And you see, even if we change the exec command to the execFile command, everything we get back is the same. So let's see how other child process methods work. First, let me comment out do something and let's see how the spawn function works. I've created a variable named spawn process which is equal to the result of calling child process.spawn. I'm passing node and the array of arguments we pass to this spawn method contains the -v flag as the argument we want to pass to the command we are running. We use the same node command. Next, we pass in an array that contains -v as arguments to this node command. We listen to the data event on the state out, that is spawn process or state out, and I just go ahead and log out that data to the console. I'm going to do the same for the state error on the spawn process, save this file and run node app.js, and the result we get back is a buffer. So we need to convert the data to a string. So I'm going to call the toString method on the data and passing UTF-8 as the format for the string. And now we have gotten the correct response, which is version 16.16.0. Inside another file, we create a function checkEven which accepts an array as its argument. We create a variable filtered which is equal to the result of calling the filter method on the array, and the predicate we pass in will filter at odd numbers and return an array of even numbers. Then we return an object that contains the filtered array. Inside the file, we call process.send and we call the checkEven function and pass an array of numbers to it. Inside our app.js file, we create a variable child which is equal to calling childProcess.fork. We pass in the path to the new file which we just created and we listen for a message event on the child and console.log the message we get from the child. Save the file, run node app.js again from the terminal, and we get back an object with a filtered property which is an array. So that's it for this video, guys. I hope you found it super useful and interesting. Leave the video a like, subscribe to the channel and turn on the bell notification so you can get access to all our videos in the future as soon as they drop. Thank you for your time and I'm going to see you in the next one.